said multi-step equations are equations where you're going to have more than one mathematical operation to isolate your variable or to get your variable by itself. Okay, there's going to be more than one step to do it. Yesterday that we learned that we use inverse operations to get variables by themselves. What does it mean to be an inverse operation? Yeah, it's kind of like doing the opposite thing mathematically, right? So what's the inverse of adding? Subtracting. What's the inverse of dividing? Multiplying, and they're vice versa, right? They are something that mathematically undo another operation. That's what an inverse operation does. It mathematically undoes another operation. So we're going to use our inverse operations to solve for variables again today, even though these equations are going to be a little bit longer, take a little bit more time, a little bit more paper. But what I have up there is kind of like a hint. It says if the variables are on the same side of the equal sign and you have the same variable repeated, then you're going to combine like terms. So there's my equal sign right there. I just drew a little highlighter mark through it. You don't have to do that. I just did it for right now. But on the left side of the equation, I have some x's, right? I have two different x's, right? Okay, so I'm not going to use inverse operations to combine these x's together because they're on the same side of the equals. So if they're on the same side of the equals, you're just going to combine like terms. Okay? Combine like terms. Raise your hand if you've heard of combining like terms before. All right. So that means like terms are when you have the same variables with the same amount of exponents. Right? So like an x squared and an x are not like terms even though they're both x's. Right? But x and x are like terms. And also constants are like terms. Do y'all know what a constant is? Have you heard the word before? A constant is a number that doesn't have a variable. So like this 1 right here is a constant, and this -5 is a constant, and that -20 is a constant. Okay? So numbers that don't have variables. Another cool word for us that we might need to know that you'll hear me say all the time is the word coefficient. Y'all heard that word before? What is a coefficient? Very good. It's the number that's in front of the variable. It's the one that's being multiplied with the variable. Very good. So constants are the numbers that don't have variable. Coefficients are the numbers that are with the variable. So, no, not usually. It means the same thing, but that's just not how we write it. Now, some people do it backwards like that, but I do not. All right. So, I have some like terms on the left side of the equal sign. I've got some x's that are like terms, and I have some constants that are like terms. When you combine like terms, you do exactly the sign that's in front of them. So that's a positive 9x minus 7x. Y'all see that? Positive 9x minus 7x. So you combine the coefficients, and what do you get? 2x. You don't change the variable. It stays the same when you're combining like terms. I just underlined them so I showed that I was just showing you the like terms. And then also, the constants are on the same side of the equals, so these are like terms. So what is positive 1 minus 5? Minus 4, and then bring down your equals -20. You don't have to leave that big space there, but I don't like my equals too far apart. OCD. I guess I can make it equal. Now, y'all, I was noticed on some of your work yesterday, if you leave off this equal sign from one step to the next, it is mathematically wrong. Okay? Your equal signs cannot just disappear from your paper. Okay? From step to step all the way to the end, your steps need to be mathematically correct. Okay? I'm very particular about you keeping your steps mathematically correct because I know what you're going to see in college. Right? I have a degree in math. And you will be counted completely wrong on some things because those guys and girls that teach in college math classes, they're geniuses. Like certified geniuses. Crazy things. All right? So Yeah, you don't want to do that. It's a pet peeve. All right, so now I've combined my like terms, and now what does this equation look like? It's like back to a two-step like yesterday, right? So what do we do first to get x by itself now that I just have one x to solve for? Add 4. Yeah, so the whole thing we were trying to do is get it to where we only have one variable to get by itself. So what is negative 20 plus 4? And now what do I do to solve for x? Divide by 2. And x equals what? Negative 8. There's your answer. Okay? So all we had to do first was combine our like terms. And then we solved it just like we did yesterday. After we combined our like terms, we were back to a two-step. So that would probably have been a three-step equation if we were counting, right? All right. Look at B. What's going on with that problem? Yeah, there's parentheses with a number in front of it, which means we're going to use the distributive property. And y'all know what distributive property is, right? You take the outside number and make sure you number it times all the terms inside the parentheses, right? Not just the first one and stop. You got to make sure you multiply times both. Now that 91, nothing's happening to it mathematically, so you're going to copy it down right now. And copy your equal sign. And then you're going to start distributing. So what is negative 7 times 3a? Very good. Negative 21a. And then you got to distribute negative 7 to negative 1 also. So what is negative 7 times negative 1? Positive 7. So you put a plus 7. It's a positive 7. If you don't put plus 7, it's going to be wrong. You're going to miss it. So watch your signs. A negative times a negative is a positive. All right. So now I've done that. And so now I'm back to a two-step equation again, aren't I? So I want to move everything away from my A. So what do I need to do first? Subtract 7. Very good. Try again. 84 equals negative 21. Hey, he's trying without a calculator. Y'all don't be fussing. Okay? Some of you, the rest of y'all are waiting on somebody else to answer. All right. So now how do I get rid of my negative 21? Divide by negative 21 on both sides. Try close. Negative 4 equals A. Very good. Hey, y'all have been deprived of math for months. It's child abuse to deprive y'all of math. No, it's child abuse. Okay, look at C and copy it down, please. It's all right. I will make up for it plenty. I'll show y'all all kinds of math love. Yes, I do. It's my job. Exactly. All right, so this one's a little bit different. It's got a few more complicated stuff. First thing we see, though, what's going on right here in this part? We got parentheses, which means we have to do what? Distribute. So before you combine like terms or do anything else, if there's parentheses in there, you need to take care of your distributive property. Okay? So is this 4m right here having anything to do with the distributive property? No. Copy it down. And what am I distributing? Negative 5 into this parentheses. Now, it's not just positive 5, y'all. It's negative 5. So when I multiply all my terms, do it times negative 5, okay? So what's negative 5 times 3m? Negative 15m. And what's negative 5 times 10? Negative 50. And then equals 126. So any questions about distributing there? Now what can I do? Not yet. Right, since the m's are on the same side of the equal sign, they're like terms. So we combine our like terms. So what is 4m minus 15m? Negative 11m minus 50 equals 126. I applaud your enthusiasm. All right, so now the reason I like to combine my like terms first is so I'm down to one variable. Okay? I personally like to get down to one variable first. Y'all with me? Okay. So now, and then I'm down to one variable, I can move everything away from that variable. So now what do you think we're going to do? Add 50. So I'm getting negative 11m equals what? 176. Yes?
So if I was to accidentally have added 50,
you can still get the right answer, yes. It's a personal preference to me to get everything down to one variable and then get it by itself. And then divide by negative 11. M equals negative 16. Y'all agree? Okay. Any questions? All right. Look at that one. My example D. You can call it number 4 if you want to. I don't care. What's going on in this problem as you're writing it? Yeah, I got 2 sets of parentheses, right? So that means we're going to have to distribute twice. Now, the first parentheses, I'm distributing what number? But what about on the second parentheses? Okay, so y'all, here's something I'm telling you. It's day 2 of this class, and that's something that I want you to do all semester long. Anytime you see a minus outside of a parentheses, I want you to stick a 1 right there. Because you're going to multiply that whole parentheses by a negative 1. And that's super cool because what happens when you multiply something times negative 1? You just change all your signs. So there you go. Okay. So on the first parentheses, we're going to distribute negative 3. So what's negative 3 times n? Negative 3n. What's negative 3 times negative 8? Plus 24. Good. What's negative 1 times n? Negative n. And what's negative 1 times 5? Negative 5 equals 23. And if you put negative 1 in right here, that's fine. Okay? So now what do you think we're going to do? Combine like terms. I've got n's that are like terms over here, and I also have constants that are like terms, right? So let's do my n's. What's negative 3n minus 1n? Negative 4n. And what's positive 24 minus 5? Positive 19. Very good. So now I have negative 4n plus 19 equals 23. I'm down to one variable, so I just got to move everything away from it. So what are we going to do? Subtract 19 everywhere. So negative 4n equals 4, and then divided by negative 4, and n equals negative 1. There we go. Any questions? All right, you guys are going to try these 2 problems on your own. I believe you can. No, you've been missing it. Got a roll of toilet paper in here. All right, if you have finished those two equations, I want you to check them over with somebody. Yeah, somewhere. Y'all getting the same thing? So the goofy thing about it is if you miss one sign somewhere in an equation, then it's gonna if you miss up one sign when you're distributing, you're gonna miss the whole rest of the problem, right? Those little mistakes don't usually fix themselves. So you got to be careful. All right, y'all ready to go over them?
Kelsey Barnes, come to the office. Kelsey Barnes.
Okay, so number one. What did you have to do first on number one? Distribute the -6. I'm going to copy the 20 equals, and then I'm going to copy the 10x because that 10x has nothing to do with that distributing, right? And then what's -6 times 2x? -12x. And what's -6 times 5? -30. And then what? Those are like terms, aren't they? Because they're on the same side of the equals. So what is 10x minus 12x? So 20 equals -2x minus 30. So now we're down to one variable, right? So we can move everything away from our variable. So what do we do now? Add 30. What's 20 plus 30? 50 equals -2x. Then what? Divide by -2. What's 50 divided by -2? Equals x. Raise your hand if you got -25 for your solution. Are there any questions about that problem? You got that? Good. Any questions about that problem? All right, number 2. What did we do first on number 2? Yeah, you need to distribute a -1 to that parentheses. So 11h, I'm just going to copy it. And what's -1 times 2h? -2h. What's -1 times -1? A +1 equals 118. Y'all okay with that step? Okay. Most common mistake is this sign right here. People forget negative times a negative is a positive, and they'll just copy whatever this sign has instead of changing it. Okay? So be careful. Now what do? Yeah, those like terms. So what is 11h minus 2h? 9h plus 1 equals 118. Then what? Subtract 1. And 9h equals 117. Then you had to brush up on your division a little bit. Not really. It's 13, isn't it? Oh, yeah. So h equals 13. I like ends. I like ends. I don't like y because y dips down to the next row, and sometimes when you do an equation, it clutters it. Yeah, I don't like J. I really don't like J's. Yeah. Okay, raise your hand if you got 13 for H. Very good. Okay. No, it ain't. Yeah, I told y'all. I'm going to make you at least tolerate them. You might not just love them, but you're going to at least tolerate them. And not go every time you see one. Okay, so the first one, you're distributing a half, right? Y'all think about it. Multiplying by a half is the same thing as doing what? Dividing by 2. So is that really that difficult? No, especially since these numbers that we're distributing to are even numbers and they're divisible by 2 evenly, right? So they're going to come out to be whole numbers anyway. Until they aren't, then you're just going to have to be a smart person and do it. Sure I did. They have fractions in them, don't they? Yeah. Yeah. And I'm friendly with fractions. I couldn't just leave them out. They'd get their feelings hurt. So yeah, distributing that 1/2 is the same thing as dividing by 2. So what's a half times 10x? 5x. Good. What's a half times negative 2? Negative 1, then copy the 3x. Was that painful? It was not. All right, now what do you think we're going to do? Like terms, they have a 5x and a 3x on the right-hand side. It's okay that they're split apart, but they're still on the right-hand side. So what is 5x plus 3x? So I'm going to say negative 25 equals 8x minus 1. And now I'm down to one variable to solve for, so what do I do? Add 1. What is negative 25 plus 1? Equals 8x. Then what? And then what do I get? Negative 3 equals x. So that was not terrible, was it? I love this. I'm so excited. Y'all copy F. Now, I'm going to show you how one way you can distribute that negative 5 over 2. And then I'm going to show you my shortcut. I have a trick. Y'all want to see my trick? Okay, so let me show you how to do it paper pencil way. So I'm just going to forget that it's negative for a second and say 5 over 2 times 8. Well, I need to put 8 over 1. And I could do just multiply across, or I could cross cancel the 2 and the 8. We did that some yesterday, right? The answer is 20, right? Or you could do it just straight across. 40 over 2 is 20, right? Right? Okay, so you just go over to your side of your paper. If that works for you, do your little multiplication, and there you go. Or you can use my trick. You want to see my trick? All right, first I'm going to copy that 7 because it has nothing to do with the distributing part. And now I'm going to multiply negative 5 over 2 times 8r. Now, I already know I'm supposed to get negative 20, right? Here's my trick. It sounds juvenile, but it's how it works. Top times big divided by the bottom. Top times big divided, and that's the same thing as putting that whole number over 1, is it not? Yeah. So it's just skipping the over 1 part. So it's top times big divided by the bottom. 5 times 8 is 40. 40 divided by 2 is 20. Yeah, it's the same thing. You're just skipping the over 1 part. And you can do it in your head instead of on paper. Now, not all of them come out to be whole numbers, so that's the tricky part, right? If it don't come out to be a whole number, you need to reduce your fraction. But that's it. Top times big divided by bottom. So negative 5 times 8 is negative 40. Divided by 2 is negative 20r. Y'all with me there? All right, let's do that with negative 6. First of all, I know a negative times a negative is going to be what's 5 times 6? 30. Divided by 2? 15. Easy peasy fractions. Plus 2r equals 32. So you okay with how we got 15?
Yes, sir.
5 times negative 6, but they're both negative, so it'll be positive. 5 times 6 is 30 divided by 2. There we go. And now what do I do? Like terms. And I've got constants and variables, don't I? Try again. No, try again. Negative 18R. And then what's positive 7 plus 15? Positive 22 equals 32. So now I'm down to one variable. So how do I get it by itself? I combined those two and got 22. Subtract 22 on each side. I'm getting negative 18R equals 10. Then what? Divide by negative 18. What am I going to have? A fraction. I'm not going to get a decimal. There was not a decimal anywhere in that problem, so you better not give me a decimal answer. Just reduce that fraction, please. What is it reduced to? Negative 5/9. Yeah, you just divide them both by 2. How do we get good at these? Practice. How do you get comfortable with fractions? You practice and do a lot of fraction problems, unfortunately. And have a good attitude. Okay, so won't you be quiet and pay attention if you want me to be a nice neighbor back? Okay, so far, all of our equations, our variables have only been on one side of the equal sign together, right? So now we're going to start seeing variables with that are on both sides of the equal sign. One's on the left side, one's on the right side. So on this problem, there's my equal sign in the middle. I have a 5y over here and a 3y over here. So I told you guys I always like to get it down to one variable before I start moving everything else. So my hint to you is get your variables together first. Because I see people trying to skip steps and do rainbow things or whatever. Yeah, and just try to do everything in one step, and they end up missing it because they try to do too much at once. So I like to tell you to get your variables together first, move them together, and then you'll only have one variable to solve for again. So to get these variables together, we're going to have to use inverse operations because they're on opposite sides of the equals, right? So do y'all want to move the 5y to the 3y or the 3y to the 5y? 3y. Now let me just tell you, it's okay if you do it a different method than somebody else. Some people will just go ahead and subtract 5y over here. I like to do it to whatever's going to make the coefficient positive. If I have a choice. Okay, sometimes you don't have a choice, right? Okay, so on this one, I like to make it where the coefficient will be positive. 3 is smaller than 5, and they're both positive. So I'm going to subtract 3y on both sides. Now 3y minus 3y makes 0, doesn't it? So those cancel out. And then I combine my y's over on the left. What's 5y minus 3y? 2y. And then copy the rest. Minus 8 equals 12. So when you're crossing the equal sign, you have to do the inverse operation. If they're on the same side, you just combine like terms. Okay? And now I'm down to a two-step equation with one variable. So what do I do now? Add 8. So 2y equals 20. And then what? Divide by 2. And y equals 10. And you can check it. 5 times 10 is 50 minus 8 is 42. 3 times 10 is 30 plus 12 is also 42. Okay, so my hint to you is when you have variables on two different sides, get your variables together before you move anything else. Unless you have to distribute or combine like terms first. Look at H. Look at H, please. Negative 6x plus 14 equals 12 minus 8x, sorry. So what do you think we want to do first? Get my variables together. Y'all want to move the 8x over? So if I move the 8x, what do I need to do to it? Add 8x. Very good, because it's minus 8x, so to get rid of it, I have to add it. Do the opposite. Yeah, I like it to be positive. So that's going to be a positive 2x. Copy the rest. I don't know. Just I must have liked that number that day I made these notes. Then what? Subtract 14 on both sides. So 2x equals -2. Then what? Divide by 2. And x equals -1. All right. Now I looks a little weird, right? It don't have as many terms as the last problem did, does it? Okay. So when you notice that this term over here has a variable, right? The little term by itself has a variable. So if you're equal to a term that's by itself that also has a variable, you want to move the other variable to the lonely variable. Okay? We want to move his little buddy, his n buddy, over there with him. Okay? Because if you move this to the other side, you'll have to put a 0 here and you're going to have a ton of steps. So these are actually quick little problems as long as you move the one that does have something else with it to the side that doesn't have anything else with it. Does that make sense? Okay, so how do I move the 3 in? I do the opposite, which is subtracting. And what is 7n minus 3n? 4n equals what? And then what? Divide by 4, and n equals -9. So yeah, that was a short little problem. It was actually a 2-step. All right. Y'all try those two. We're getting there, y'all. We don't like much. Let me know if you get stuck. Watch your arithmetic. Regular action. There's this mistake. I'll show you about it. Like this father's dancing my board because I got mad. Exactly what she said. Yeah. Anyways, but there's this thing that people make the same mistake on over and over, and then they go to Algebra 2 and make the same mistake, and they go to college and make the same mistake. Well, I tell kids I will take a red ink pen and break it in front of that problem. Empty all my ink. Okay. Y'all check your answers for those two with somebody. And y'all, we're practicing. We're practicing and helping each other. It's okay. Don't beat yourself up if you miss a sign or miss multiply. All right, something you might notice is, like on number 1, some of you might have added 2x to both sides, and some of you might have subtracted 9x from both sides, right? Is that okay that you can do it 2 different ways? Absolutely. But we still should get the same answer. I know there's some people that no matter what, they move the variables to the left. They don't like the variables on the right. It doesn't bother me anyway, I just go with it. All right, y'all. After we go over these 2, we'll have 3 more examples. That's it. Okay? So 5 more counting these 2. So, y'all help me out real quick. What do I want to, what's something I could do to get x by itself? Yeah. To get them together first, right? Yes, I could add 2x to both sides. I could subtract 9x on both sides. Raise your hand if you added 2x first. Raise your hand if you subtracted 9x first. All right, good deal. Well, I'm going to do it this way, and if I need to work it for somebody else the other way, I will. Y'all stop talking, please. Okay? So if you want me to see it the other way after I do it this way, just tell me, and I'll do it the other way too. So this, you get me 12 equals what? 11x plus 45, and then what? Subtract 45. What is 12 minus 45? Negative 33 equals 11x. And then what? Divide by 11, not negative 11. And what do we get for x? Negative 3 equals x. Raise your hand if you got negative 3 for your first answer. Do I need to work it the other way? Anybody need to see it the other way? Okay, good. Number 2. Somebody tell me what you did first on number 2. All right. Could you have added 7 in? Yes. Hey, raise your hand if you added 10 in. Raise your hand if you added 7 in. Okay. About the same. I'm going to add 10 in because I'm like some of y'all. I like it to be positive. So if I add 10 in, I get a 40 plus 3 in on the right-hand side, right? And then I want to get in by itself, so what do I do? Subtract 40 on both sides. What's 1 minus 40? Equals 3n. And then I divide by 3. And what do I get? Negative 13 equals n. Raise your hand if you got negative 13 for your final answer. Do I need to work it the other way for anybody? All right, good job. All right, what's the last thing we got to do? Distribute and have variables on both sides. Okay, yeah. This is just throwing it all together. Throwing it all together. This one has distributive property and variables everywhere. So copy problem J, please. I don't know how many steps. We'll count them later. Yeah, copy it correctly, please. That's something helpful about doing worksheets for practice, so you're not like copying from a book and miscopying things on your paper. Yes. Okay, so that's a very good hint. Anytime you see distributive property in an equation, that's what you want to simplify first, is to get rid of your parentheses. Okay, so that's what I'm going to do first here. So what is 9 times m? 9m. And what's 9 times negative 3? Negative 27. And I'm going to copy everything else exactly like it says. So far, so good? Now what I like to do is look at each side of the equal sign and see if there's any like terms. Are there any like terms on this side? What are they? Yes. So then I combine my like terms if they're on the same side. So what is 9n plus 3m is 12m. Good. Minus 27. And were there any like terms over here? No, they're different. So I'm going to copy those for right now. Okay. So now I've simplified each side separately. So now I can start crossing the equal signs. Now, after I do that, I want to get my variables together first. So somebody tell me one way I can get my variables together. Subtract 7m. And what is 12m minus 7m? So 5m minus 27 equals 43. Now I'm finally down to where I only have one variable. So all I have to do is clear everything away from that variable and solve for it, okay? So now what can I do? Add 27 to each side. So 5m equals 70. And then what? Divide by 5, and m equals 40. Very good. So that wasn't terrible, was it? So we distributed, combined like terms, subtracted, added, and divided. So that was 1, 2, 3, 4, 5 operations. No. All right, y'all can't see all of that next problem, so I'm going to slide that over. So this is literally the hardest thing we'll do all day. So all of your problems that you're going to have to do for practice are not going to look this way. Trust me. Maybe a few. Maybe like just one. Yeah. This is honors. We got to be challenged a little bit. Just enough for a healthy amount of stress. All right. So, what do you think we're going to do first on problem K? How many times are we going to have to distribute? Good. We have 2 sets of parentheses, so we'll distribute twice. What are we distributing in the first parentheses? -1. Very good. So 5x is not being distributed or anything, so I'm going to copy that. And then what's -1 times x? And -1 times -18? +18. So there's the left-hand side of the equation. And on the right-hand side, what are we distributing? -2. So copy your 6 because it doesn't have anything to do with the distributive part. What's -2 times x? And what's -2 times 15? -30. Very good. So what do you think we're going to do next? Yes, look at each side of the equal sign and see if there's any like terms. Are there any like terms over here? Yeah, the x's are like terms, aren't they? So what is 5x minus 1x? 4x, and I'm just going to copy the plus 18. Equals, are there any like terms on the right-hand side? Yes. Yeah, the constants are, aren't they? So +6 minus 30 is what? All right, so I'm going to have -2x minus 24. Does it matter what order I put these two terms? No, it does not. Okay. Okay, so now I have each side simplified. Now I can start getting my x's together, right? That sounds like a bad party, getting your x's together. It won't end well. All right, so how do we get our x's together? You can subtract 4x or add 2x. Some of y'all are still in the real world instead of the math world. 4x plus 2x is what? 6x plus 18 equals negative 24. Now what? Subtract 18. I don't think some of y'all are talking about this problem. And 6x equals what? Negative 42. And then what? Divide by 6. And x equals negative 7. Seriously, y'all, it's as hard as it's going to get with long equations, right? That's probably the longest type we can see when it's just equations. I want you guys. Oh, it's easy. Try this. Oh, and maybe it's not. It is. Last one. Y'all try that one. It's not bad.
Is this number 8 or is it 8 like?
It's part of the problem. I didn't put a number with this one.
Oh.
You can call it whatever number you want. Usually, if it's a you try problem, I usually put a star. Only missing 4 more info sheets. All right, the ones of you that are finished, some of you still working, that's okay. The ones of you that are finished, go ahead and check it with somebody. Check it with somebody. Oh, that's right. 8 buckets, 30 times, so you right, so that means it's not the same right there. That's correct. So then you combine like right here. Yeah, you subtract the 3 lines to add it. All right, let's wrap it up so y'all can start on your practice, okay? So, what did y'all have to do first on this problem? You did distributive property. How many times did you have to distribute? 2 times because you have 2 sets of parentheses. So on the first time, what's 8 times y? 8y. What's 8 times 4? Positive 32. Then you go to the next parentheses. What's negative 2 times y? And what's negative 2 times negative 1? Positive 2 equals 70 minus 3y. Everybody okay so far? Then what? Like terms. So over here on that left side, I got 2 sets of like terms. I've got variables and constants, right? So my y's, what's 8y minus 2y? And then what's positive 32 plus 2? Plus 34, good. And then that equals that 70 minus 3y. Fix it.
I put a negative 2.
Okay, so y'all, the most common mistake right here would be this part right here that I've seen. I mean, I've been doing this for 13 years. This is where I see the most common mistake is people not changing the negative times the negative to a positive. You gotta get your multiplying and subtracting correct. Okay, so now we got a y, y'all. Now we have a y on both sides, right? Somebody tell me one way I can get my y's together. Add 3y. I could also subtract 6y, couldn't I? What's 6y plus 3y? Plus 34 equals 70. And then what? Subtract 34. What's 70 minus 34? So 9y equals 36. Divide by 9. Y equals 4. Raise your hand if you got y equals 4 for your final answer. All right. So that concludes notes for today.